Today we will discuss the effect of Coriolis force on freely falling body. You know that second part is Coriolis force. What is Coriolis force? It is fictitious force which is written as minus 2 m omega cross v. This is Coriolis force. First of all, we will find the value, magnitude and direction of this Coriolis force. Then we will find the effect of this force on freely falling body. So first of all, what is Coriolis force and effect of Coriolis force on freely falling body. Freely falling body. So this force deals with the object in motion because velocity is involved as one term in Coriolis force. Therefore, we have to consider the object in motion. Therefore, we will take freely falling body. Falling means it is moving from higher point to lower point, that is in motion. So velocity should be there. Therefore, we will consider freely falling body. We will not consider the body at rest. We will consider the body in motion. So what is Coriolis force? First of all, we have to prove it. Coriolis force is equal to minus 2 m omega cross v. Our first step is to solve or to resolve these vectors into components. So consider the components of omega vector and v vector. We have to draw a diagram. Vector diagram. This is an earth and this is origin or center of earth, and here is any point. That this point is m point or n point, and this is the radius of the earth. Now in this case, especially in Coriolis force, we will consider the origin at n point, this point, on the surface of earth. In the previous case, that is in centrifugal force, we have considered the origin of the earth as origin of the coordinate system. But in this case, we will consider origin on the point, at the point lying on the surface of earth. So we will consider n as origin. So we have to draw the direction that this vector, which is along the line joining between O and. So this vector is, or this axis is z axis. Actually, there are three different axes which we have already considered, but now we will not consider these axes as axes in this case. We have to draw a new coordinate system, that is at point n. So this is z axis, and the perpendicular to z axis, this is y axis, and the perpendicular to both y and z axis, because y and z axis are lying in this plane like this, and x axis is along this side inward. So this is x axis, y z axis, it is y axis and x axis. So x axis is inward to the board. Let z axis is like this, x axis. So this, actually this is not x axis. The x axis is totally inverted, which is inside the board, because y, z and x in this case, x, z and y, like this. So x, y, z, this is our coordinate system we will use in Coriolis force. Now, what is omega vector? We know that omega is the velocity of earth, this is, and it is always perpendicular toward this side. And omega, if we draw this omega at n point, then this omega is like this. Okay, it is parallel to this line, omega. And the angle formed omega with the y axis is lambda, that is angle of latitude. So vector omega, this vector is lying between y and z axis, as vector omega lies in yz plane. So we can resolve this omega in two components. that is omega vector is equal to omega cos lambda j, because it is omega, and along this side it is omega cos lambda because angle is formed with y axis, and along this side it is omega sin lambda plus omega sin lambda into k. So these are the components of omega vector. And what is v? V is the velocity. So we will consider freely falling body. So body is placed here, I put here, and I leave it this body freely under the effect of gravity. It will move toward this side, along this side. So velocity is negative z-axis. Velocity is along negative z-axis. So what is velocity? Velocity is v and minus k. Okay, v and minus k. So this is, now put the value of omega and v in this force. So we will get Coriolis force is equal to minus 2m. Omega means omega cos lambda j plus omega sin lambda into k is omega, and cross multiply with v vector. What is v? It is minus v k, because v into minus k, that is minus v k, v into k. Now we will multiply minus 2m, we will multiply this term with this. So j cross k is I, and it is minus omega cos lambda into v. Omega cos lambda into v, that is omega cos lambda into v, and j cross k is I, and plus 0, because it is k cross k is 0. So therefore the value for force, Coriolis force, is equal to just minus 2m into this, minus into minus plus 2m omega v cos lambda, 2m omega v cos lambda into I. So this is the exact value of Coriolis force. So this one is magnitude, that is magnitude is 2m omega v cos lambda, and direction is along I, means along x-axis. It means this force, Coriolis force, is acting on the body towards x side, means it will pull the body towards inside, inward. So when body is freely falling under gravity, it is supposed that it is going toward this side at end point, but actually it will not fall at end point. It will displace towards some x-axis. Actually it will fall at end dash point. Why? Because this is due to Coriolis force. Because the force is acting on the body when body is freely falling under gravity, it has to fall at this point. But the constant force, this force, Coriolis force, is acting on x-axis. Therefore, it will displace, that this will displace, and it will go this side. So there is some displacement on the actual position, from the actual position of the body. So this is the article which we are studying. Now we will find the effect of this Coriolis force on acceleration due to gravity or freely falling body. So this is the force. So what is the effect of this force? So this force is acting only along I, means x-axis. So this force may be resolved as m into x double dot, because F is equal to ma. F is equal to ma, and a means acceleration. So we will consider only x component because it is along I side, x-axis. So m into x double dot. So m x double dot is equal to 2m omega v cos lambda. Okay. So I have compared the magnitudes on both sides. F is written as ma, direction is I, because I am considering only I component, and it is also I component. So m is cancelled with m, and x double dot is equal to 2 omega v cos lambda. Okay. So we will put the value of v by using freely falling body. You know that when body is freely falling under gravity, its motion is uniform accelerated motion. So we will apply the formula for uniform accelerated motion to calculate the value of velocity. So what is formula? So we have three formulae, that is v is equal to u plus at, s is equal to ut plus half ad square, and v square minus u square is equal to 2as. So these three formulae have been used to find the resultant or the motion of the object which is moving in uniform accelerated motion. Okay. So I am using this v is equal to u plus at. So what is v? V is v because we have to find v. What is u? U is 0 because we have dropped from rest. Particle is dropped from this point at rest. So u is 0. And what is a? A is to this side. A become minus g. Okay. Or in magnitude it is g because under gravity it is g in magnitude and t is t. So this v can be written as gt here. Therefore, what is the value? We will get x double dot is equal to 2 omega into gt into cos lambda. 2 omega gt into cos lambda. Now, we will find displacement. So it is x double dot. We will take its integration. So integrating both sides, we will get x dot, because when we take the integration of double dot, so the one derivative will be removed because it will cancel with the integration. So x double dot become x dot on integration. It will become 2 omega gt into cos lambda. On the integration of this, it is 2 omega g and cos lambda are constant, and integral of t is t square by 2 because variable is t. So 2 is cancelled. Therefore, x dot is equal to omega g cos lambda into t square. Similarly, again integrating both sides to get x, because integral of x dot is x. X dot means derivative of x, dx on dt. When we do its integral, then derivative will cancel with the integral and we will get x. And integral of this on the right hand side, it is omega g cos lambda into t square into dt, because dt is variable, t is variable, therefore integral must be with respect to dt. So it is omega is constant, g is constant, cos lambda is constant, and integral of t square is t cube by 3 plus constant is there, but constant is 0. So x become 1 by 3 okay, omega g cos lambda into t cube. This is x. So we will put the value of t by using again the formula for uniform accelerated motion. S is equal to ut plus half at square. Okay. It is again formula for uniform accelerated motion. So what is S? Let the body is dropped from this point, and the distance from this point to end point is h. H is the height, means height. It is height from where the body is dropped. So S is taken as h. U again 0 because initially the body is dropped from rest point, and plus half into a becomes g because it is moving under gravity, and t square. Okay. And half gt square is equal to h, or t square is equal to 2h upon g, or t become 2h upon g square root. Okay, t square is 2h upon g, and t become under root of 2h upon g. So putting this value of t here, and this is displacement, that is 1 by 3 omega g cos lambda to t cube, means 2h upon g raised to power 1 by 2 and raised to power 3, and will become raised to power 3 by 2. This is actual value of displacement. X means displacement. So it is that displacement, this is x. So it is that distance at which the body is actually falling instead of n, because the body has to fall at point n actually, because under gravity it will move toward this side and it will strike on the surface of earth at point n. But due to Coriolis force, it will not strike at this end point, it will strike at n dash point. So the distance between n and n dash, it is x, because this x is derived from the force, Coriolis force. So Coriolis force affect the displacement or actual motion of the body actually. So this is displacement. So in this way, there are so many other effects are also there of Coriolis force.